This first unit is going to be all about radicals. What's a radical? Or can you give me an example of a radical? What's so special about a radical? What does every radical contain? What kind of symbol? Right. Okay. Anything that has that symbol in it. Now, you guys are used to seeing no number here, some number under here. And that we would call the square root. But last year, we learned that we can have the first here. Square root, technically, there should be a little 2 there. Cube root, 3. Fourth root, 4, and you can keep going. So, as part of a radical, we have a little number on the outside there. That little number we call the index. And whatever's underneath the radical sign is called the radicand. You don't have to know the definition of those, but you should be familiar with those words. Okay? So last year, we did things, and even prior years. What's the square root of 64? 8. What's the cube root of 27? 3, because 3 times 3 times 3. What's the fourth root of 16? 2, because 2 times 2 times 2 times 2 is 16. What's the square root of negative 64? Sorry? Can't do it. Because there's no number times itself that gives you negative 64. Because if you try 8 times negative 8, those aren't the same numbers. If you try negative 8 times negative 8, that gives you positive 64. Okay? So, there are certain restrictions when we are dealing with radicals. And it specifically applies to square roots, fourth roots, sixth roots, all the even roots. Okay? If you are ever taking an even root of a number, and the most common one we'll do is square root, what's under the radical, the radicand, must be a non-negative number. I don't say positive number, because if I say positive number, I'm not including 0. It has to be greater than or equal to 0. So the big difference this year with radicals is we're going to start dealing with ones that have variables under the expressions. You saw a little bit of that last year. We talked a little bit about that. But the first thing we want to do when we're dealing with radical expressions is we want to say, okay, what are the restrictions? What can x be? What can't x be? Would you all agree that for this expression, whenever I plug in for x, when I times it by 5, it has to be greater than or equal to 0? Like I can't say x is negative 2, can I? Because negative 2 times 5 is negative 10, and I can't take the square root of negative 10. I can't say x can be negative 10, because negative 10 times 5 is negative 50, and I can't take the square root of that. I can say x is 0, because 0 times 5 is 0, and the square root of 0 is 0, so that works. And I can take any positive number. I could take 1. 1 times 5 is 5, and the square root of 5 is 2 points. So in this one, the restriction would be x must be greater than or equal to 0. I can use this expression as long as x is 0 or bigger. That's the restriction. I can't use the expression if x is less than 0.
So how do we do these other ones? A minus 5, square root of a minus 5. What are the restrictions on a? What can a be? Well, would you all agree then that whatever a minus 5 has to be bigger than or equal to 0? So do that. Well, we solved these things back in grade 9. How do you solve an inequality? Same way you do an equation. Add 5 to both sides. A must be greater than or equal to 5. So that means I can use this expression as long as a is 5 or larger, which makes sense. Because if a is 5, 5 minus 5 is 0, I can do it. If a is 6, 6 minus 5 is 1, square root of 1, I can do it. But if a is 4, 4 minus 5 is negative 1, I can't do it. So to find the restrictions is pretty straightforward. All you have to do is take what's under the radical and make it greater than or equal to 0 and solve it. So for this one, see, the expression a plus 8, whatever I plug in for a, when I add 8, the answer must be greater than or equal to 0. So therefore, a must be greater than or equal to what? Negative 8, because we just subtract 8 from both sides to get a by itself. And that makes sense, because if a is negative 8 plus 8 is 0, I can do it. If a is negative 7 plus 8 is 1, I can do it. But if it's less than this, negative 9 plus 8 is negative 1, I can't do that. And for this last one, again, just take the expression, take the radicand, make it greater than or equal to 0, and solve for your variable. So this is a two-stepper. So I have to add 3 to both sides to get 2x is greater than or equal to positive 3. Therefore, x must be greater than or equal to 3 over 2. And you don't have to change it to a decimal, just leave this a fraction. Okay, so that's one thing we got to be careful with when we look with radicals. Is what are the restrictions on? What are we allowed to use for the variable? A couple of questions to get you to think a little bit. Why is there no restrictions to this? The square root of a squared. Just hang on, I just want people to, yeah, Avery? Right, because if I put 0 in here, I get 0 squared is 0, square root of 0 is 0. It works. I can do it. If I plug any positive number in here and square it, yeah, I can do it. It works. If I plug any negative number in here and square it, it becomes positive. So it works. That means I can plug any negative number in, any positive number in, and 0. Or there's no restrictions. Okay? So there are no restrictions on this because a squared is always positive. And if it's always positive, we can square root it. Well, the cube root of x. Why is there no restrictions on the cube? Well, think about a number that we can take the cube root of and get a whole number answer. What could I take the cube root of and get a whole number answer? Cube root of. Sorry, 27 is 3. What about if I put a negative in front of the 27? Cube root of negative 27. Sorry, 3, negative 3, right? Because negative 3 times negative 3 times negative 3 is negative 27. So that means I can take the cube root of any positive number. I can take the cube root of any negative number. What about the cube root of 0? Yeah, I can do that. So that means I can take the cube root of any number for x. So if we think of an example, okay, so the cube root of a positive is positive. The cube root of a negative is negative, which means I can do them. And the cube root of 0 is 0. Well, I've just covered all the numbers, positives, negatives, and 0. And whenever I put a cube root in there, I'll get an answer. And that will apply to 5th roots, 7th roots. So every even root, there'll be restrictions. Every odd root, there won't be. Okay? And we're really going to just deal with square and cube roots. So really, there's restrictions for square roots. There's no restrictions for cube roots. That's really what you have to do. Okay? All right, so radicals. Well, let's fractions. We can do a lot of stuff with radicals. We can add them. We can subtract them. We can multiply them. We can divide them. We can simplify them, much like reducing fractions. We did simplifying last year. Right? So just a couple of terms, and we talked about these last year. An entire radical is a radical that basically has no number in front of it. So square root 12, cube root 9. Okay, no big number in front of it, I should say. It can have a root number. Or root 10, that's it. A mixed radical does have a number in front of it. So it would be like 2 root 12. Or cube root 9. Negative 6, 4 root 10. And we learned last year that we're radicals, and we basically talked about, we did a little bit of cube root, but we talked mainly about square roots. There are entire radicals, like root 12, that we can simplify to a mixed radical. So root 12, do you remember how to do it? This is when we want to break it down. There's 2 radicals that multiply to get root 12. But the first number that goes into 12 must be the highest perfect square. Why do we take the highest perfect square? Because we can square root it. So you got to remember your perfect squares, starting from 4, 4, 9, 16, 25, 36, 36, etc. What's the highest perfect square that goes into 12? 4. Which means that root 4 times what is 12? 3. So I just broke up root 12 into root 4 times root 3, but root 4 is the same as 2. Root 3, I can't do without a calculator. And I don't want to use a calculator. So that's simplified. Some students ask if I can do this in my head, do I have to show the work? Nope. Don't have to. but I would suggest to start, maybe you do, just to remember things. All right, we got to break this up. I don't know why it just keeps putting random things. Root 54. First one has to be highest perfect square, Alyssa. 9, which means the other number must be. And therefore, the simplified answer is 3 root 6. Cube root 32. Now remember, you've got to think of your perfect cubes because you're finding 2 cube roots that multiply to 32, where the number under the first one is the highest perfect cube that goes in, and your perfect cubes are 8, 27, 64, 125, yeah, 84. And therefore my final answer is yeah. I know, it looks a little weird. Just remember, don't write those two numbers the same size. Because this coefficient, this index. Okay, back to square roots. We'll do a few square roots. What's one thing you got to be careful when you're simplifying? Sometimes more than one perfect square goes into it. That happens in this case. Many of you might look at this and automatically think 4. 4 is a perfect square that goes into it. But is it the highest? What is the highest? 16. And what times 16 gives you 85? And therefore, the simplified answer, root 16 is the same as 4 root 5. And we're done. I think you guys can do the next 2. I think we're back into a bit of a rhythm now. Give it a shot. First one, E. What does it break down to? 4 and 13, which further simplifies to 13. Second one breaks down to 100 and then 2, which further simplifies to 10. So those questions were reviewed from last year. You can see that these next ones are different because not only do they contain numbers, they contain variables that have exponents. Okay. The first thing when we encounter one of these is split the number with the variable in the exponent. And we're going to simplify each one. Root 48 breaks down to 16. the square root of x to the sixth, and this is why I gave you that front page on the lesson sheet. A list of perfect squares and perfect cubes, not only of numbers, but of exponents. Can I take the square root of x to the sixth? What times itself, you got to think of your exponent, Bob. Remember, when you multiply exponent, or when you multiply powers, you add the exponents. What power times itself gives me x to the sixth? X to the third. Because x to the third times x to the third is x to the 3 plus 3, which is x to the 6. So this is exactly x to the third. Remember, all of these are being multiplied. So imagine that there are multiplication dots between them. You don't have to write those. So we keep simplifying as much as we can. Well, what's the square root of 16? 4. So I've got 4 times root 3 times x to the third, but that doesn't look very good. Okay, what we should do to make it clear is anything that's not under a radical goes first, and anything that is under a radical goes after. So remember, these are multiplied. So 4 times root 3 times x. What? Four times root 3 times x to the third means the same thing as 4 times x to the third times root 3. So that's what our final answer is going to look like. So you see, we've got to do a little bit of extra simplifying and then combine by multiplication at the end. Okay. So B. Split. First thing you do. Square root of 24, you should be pretty comfortable with. Breaks down to 4 to 6. The square root of x to the 9. Well, there is no number time, there is no power times itself that gives me x to the 9. So what I need to do is I need to find the highest perfect square. What's the highest perfect square? Well, what are perfect square exponents? 2, 4, 6, 8, 10, etc. What's the highest one that goes into x to the 9? X to the 8. So what I'm going to do is I'm going to put 8 of the x's being multiplied by themselves there. How many are left here? Just 1. Now, I can take some of these square roots. The square root of 4 is 2. The square root of 6 I can't do without a calculator, and that's not what I'm doing. What's the square root of x to the 8? X to the 4th. And the square root of x I can't take. So I got to leave it at that. And now we just put it in the proper order. Anything that's not under a radical, put it together by multiplication. Anything that is under a radical, we could put it together under one big one. So root 6 times root x is the same as root 6x. You don't have to write the square root separately. Any questions? Are we sort of, I know this is new. Okay. Let's look at a few more. Right, yeah. Or one more simplifying before we go the other way. We got cube root. Again, split the number and the power.
cube root 24, cube root k to the 7. Well, nothing times itself, no whole number times itself equals 24, so we're going to break it up. I can't take the cube root of k to the 7 because nothing times itself gives me k to the 7. So I've got to split that one up. Now remember, we're cubes now, so for numbers, think 8, 27, 64, 125. What's the highest perfect cube? It goes to 4. We're going to have 8, which means this must be. And again, you can refer to that table on the front of the lesson package I gave you. What's the highest perfect cube that goes into k to the 7th? K to the 6th. K to the 3rd is a perfect cube. K to the 6th, K to the 9th, every multiple of 3. Every exponent that's a multiple of 3 is a perfect cube. Every exponent that's a multiple of 2 is a perfect square. Well, if I've used 6 k's being multiplied by themselves here, there's only one left here. Next step, do the actual ones you can do. Cube root of 8. 2. Can't do this one. Cube root of k to the 6th. K squared, because think about it. K squared times k squared times k squared is k to the 2 plus 2 plus 2, which is k to the 6th. This last one I can't do. And now I just have to put it in proper order. Everything that's not under a radical, connected by multiplication, 2k squared. Everything that is under a radical, put it under one big radical, cube root of 3k. So it looks a little weird. Because you've got an exponent, then you've got an index followed by each other. But that's how we write it. So that's how we simplified radical expressions. You guys were familiar with simplifying radical numbers. Now we've added expressions to the mix. And remember, all of those questions, we were going from an entire radical to a mixed one. What happens if we go the other way? And that's the last thing I want to talk about. These are all mixed radicals. How do I make them an entire one? So how do I'm dealing with square root. How do I make it into an answer that looks like that? I'm dealing with a square root. How do I make this into an answer that has just that? I'm dealing with this. How do I make an answer that has just one cube root and something underneath? Well, easiest way to do it is take a non-radical and change it to a radical. This is a radical form. 5. How could I write that 5 as a square root? Square root 25. And we're familiar with how to multiply radicals together. Root 25 times root 3 is 75. There you go. So how did we do that? Well, we just did 5 times 5 to get 25. So think of that same reasoning when you look at the ones that have variables, right? Well, I don't have to touch this, but I have to change this by doing a to the 3rd times a to the 3rd, which gives me square root of a to the 6th.
And square root of a to the 6th times square root of a, or square root of a to the 1st. Square root of a to the 7th. And this last one, well, I don't have to change this because it's already in cube root form. But I do have to change 4x. How do I change it to cube root? I got to do 4x times 4x times 4x. What is 4 times 4 times 4? What is x times x times x? So that means it's going to look like that. And then to get the final entire radical, I just multiply those two together. So 64 times 2 is 128. X to the 3rd times x, or x to the 1st, is x to the 4th. That would be the most challenging one you would see. Okay. But the most challenging ones would be ones like this one here, we're going from entire to mixed, and this one here, we're going from mixed to entire. Right? Okay.